Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq bin Azmi. My matric card number is CE190151 and my supervisor name is Dr. Erfa Rizanis binti Baharudin. So my project is basically for monitoring heart condition patient with ECG sensor. So for the introduction, our heart is the most vital organ in human body since it pumps continuously from the moment we are born and continues to beat even when we are sleeping. So heart attack are becoming more common among Malaysians in their 20s and 30s years old. So heart attack is a main disease in Malaysia basically. So statistics show that heart disease also remain the principal cause of death for all the major ethnic group. So 16.6% for Bumiputras, followed by 16% Chinese and 22.8% Indians. Next, our problem statement. Firstly, there is no early detection for heart disease patient that could save their life if we can compare a normal heartbeat and an abnormal heartbeat. So, my monitoring system can detect earlier the normal heartbeat between an abnormal heartbeat, so we can prepare early. So, secondly, heart patient failure can go to the hospital on their own. So if they are prepared earlier, so can get medical advice earlier. So so go to objective. So my first objective is to develop a software for comparing a normal and abnormal heartbeat. So we use Arduino and MATLAB to compare a normal and abnormal heartbeat. Secondly is to develop hardware for a heart monitoring system. We are using a, ECG sensor for a transducer and the Arduino Uno board as a microcontroller. So third, to analyze the complete system performance with several heartbeat condition. So I'm using Arduino and the wave of ECG goes to MATLAB and we can analyze several heartbeat condition and we can compare it. So next, scope of project. First, to monitor a patient with a heart patient failure by monitoring the waveform of ECG and the heartbeat of their pulse with ECG sensor. So I'm using AD8323 for a transducer. And second, to implement a MATLAB to the system and can analyze waveform from the Arduino IDE. So we analyze first the waveform at Arduino, and the waveform we go to MATLAB and we can detect several heartbeat there to ensure that the heart patient failure can get a daily checkup only at their house to monitor the heart condition. So basically, if they not have a ECG monitoring system at their house, they can go to hospital, but it really costly to them. Next, for hardware, I'm using Arduino Uno. So the Arduino Uno is an open source microcontroller board based on the microchip ATmega 328P microcontroller and developed by Arduino. The board is equipped with set of digital and analog input or output pin that may be interfaced to various expansion board and other circuit. So next, ECG sensor. So I'm using the CE190151 232 ECG sensor is a commercial board used to calculate the electrical movement of the human heart. This action can be charted like an electrocardiogram, and the output of this is an analog reading. Electrocardiogram can be noisy, so to reduce the noise, the AD8232 chip can be used. So lastly, three lead ECG cable. ECG lead connect patient applied method to telemetry and bedside monitoring equipment, enabling for non-invasive monitoring of the heart critical improve over time, setting in an electrocardiogram. So next, software. I'm using Arduino IDE. So the Arduino Integrated Development Environment (IDEs) is a cross-platform application that connects to the Arduino board and is created in the computer language C or C++. The programming language will be compiled, and the software will utilize to program this project. It may upload to the Arduino board from the compiler language, and the Arduino will work according to the code. Next, MATLAB. So MATLAB is a programming platform designed specifically for engineers and scientists to analyze and system and product that transform our world. The heart of MATLAB is a MATLAB language, a metric-based language allowing the most natural expression of computational mathematical. So after do the comparison between the research paper and project in the literature review, in this monitoring ECG system, I decide to make a development by using a ECG sensor as a transducer. As for the microcontroller, Arduino Uno is chosen because Arduino Uno is easy to find and use. After that, for the software MATLAB and Arduino IDE is chosen. The software is to run encoding and as an interface of ECG waveform. So for the plot diagram, firstly from the plot diagram, show a subject will be pair a pin from ECG cable to their chest to measure a subject heart rate. The hardware that being chosen is a 3-pin ECG cable and ECG sensor. From that, the ECG waveform will be transferred to the Arduino IDE. Arduino IDE will read ECG waveform and store it. The ECG waveform then goes to MATLAB to be analyzed. The ECG waveform will be filtered and out to output will be analyzed to find a person heart rate. The normal heart rate for a normal person is 60 to 100 ppm. Lastly, the data will be shown and the person will get know the heart rate the normal or not. So for the schematic diagram, so figure show the schematic circuit of the detecting unit, and this unit consists of Arduino Uno as a microcontroller, ECG sensor as a transducer, and 3-pin ECG cable to attach at human chest. This component function to detect a human electrocardiogram waveform. First, the Arduino Uno is processed the data from the sensor. Then the ECG sensor will detect the ECG waveform from a human heart. So next, type of arrhythmia and the heart rate. So from the table show, a type of arrhythmia and the heart rate. We know that normal heart is between 60 to 100 beat per minute. But if the person have a heart disease or heart rate, maybe can be high or low. The heart rate is the high heart rate is named tachycardia, and the heart rate is over 100 for the adult heartbeat. But it also dangerous when our heart rate is lower. Heart rate lower is called brachycardia. The heart rate range for brachycardia is lower than 60 ppm. Flow chart. In figure show the algorithm of detection unit. This algorithm to show the process detection system run and working. The algorithm start with initialization, which is to diagnostic tests are run and the operating system is loaded. Then it will continue with ECG sensor, analyze the ECG waveform from the subject. Next, it will go to processing data. The data will process in an Arduino IDE software. Next, data will go to MATLAB to be filtered and analyzed. So ECG introduction. So an ideal ECG is look like in the figure, um, and it keep repeating itself. So we will try to detect a peak in this presentation. So the figure one show the all component that have that be attached together, and the next figure is a 3-pin ECG that must be placed. So it has two way to get, to attach to a human body. So in this test, the ECG waveform is test at normal condition and abnormal condition. The test is conducted at steady state and another one after running condition. So we can analyze that ECG waveform was most faster than a normal condition at a running condition. The heartbeat is also a little bit increased from a normal condition. The P wave and T wave also shown a different. The amplitude of gap is much frequent than the normal ECG waveform. So lastly, the result for the final year project one. The project is successfully to accomplish one of the function in part of to stimulate ECG waveform in Arduino IDE. Using Arduino Uno to stimulate and send waveform to MATLAB to be analyzed. It able to monitor from time to time the ECG waveform and can get a reading of BPM to their recommendation for future work. Since this is the first phase of the project are only able to come up with a ECG waveform. Then for the final year project 2, this project will continue for MATLAB part, which is up to our peak, uh, and give a notification for user. Next, the future work will be integrate between hardware and software, which is Arduino part and MATLAB part. Lastly, I hope this multi-system can be functioning well and can give a convenience to the heart disease patient to monitoring the heart condition. So that's all from me. Thank you.